Good morning. My name is Greg Lippa, and I am an instructor with Themis Education. You can see on the home slide some information about me and Themis, and you're more than welcome to contact me or Themis with any questions you have about this presentation or about training in general or about technology. Got quite a few staff on board who can help out with all kinds of different technology, mainframe and distributed, and Java. Java's been my specialty for about close to 20 years now. I was a mainframe guy and still am, especially when it comes to DB2 and COBOL and stuff like that. But our presentation today is not about COBOL or DB2. It's about Java and unit testing with Java, testing in general. So you can see on our home slide the subtitle, Why It's Important and How to Do It Well or Effectively. So some of you have probably attended webinars that I've delivered before, and you know they're always pretty jam-packed. If you look at the bottom line there, we'll have very little time for questions. I'll try to make some time at the end, and I'll stay on, after the 45 minutes, and we can take some questions. But here's what we're going to look at. What is unit testing? I think we all probably have a sense of that, but how important is it? How does JUnit work? Of course, if you're writing Java, you're very likely using a tool, maybe Eclipse. We're going to be demonstrating in the slides how JUnit works with Eclipse and what a test case is and what you should test and how you should test them. How do you execute those tests? How do you group tests together in a suite? A few best practices, and then a very brief look at what's coming up in JUnit 5, which is in beta. It's due out later this year. So you have my email address there as well as the Themis information on the title slide. If it's not clear to everyone, the slides are available from our website. So you can go to themisinc.com webinars and download the slides for this or any other of our past presentations from the Themis Inc. website. So let's get started. We do have about 45 minutes allocated to this, and again, I can stay on and answer a few questions at the end as well. So why unit test? Now we've got some major points here. We want high quality code, that is code without defects, code that works and doesn't blow up. We want to find bugs, and we want to find them as soon as possible. You probably heard the story about the later you find them, the more it costs to fix them. So finding them early in unit testing is the best case scenario. Finding them at the last possible point after it's gone to production is a worst case scenario. Has impacts for the organization as well as the cost of fixing. Of course, we test to make sure we've supported all the requirements. And one of the other things that testing does is increase the developer's confidence in their code. You think you coded it right, you think you met all the requirements, but are you really sure? By having a thorough suite of unit tests, you can have that confidence, and this is important when it comes to things like refactoring. I want to change this code and improve the design a little bit, but I don't want to break it in the process. It works. So if I'm confident that I have a set of unit tests that will ensure that the code is clean after I make the changes to refactor, that's another benefit. Of course, there's plenty of excuses for why developers do not unit test. No time, too complicated, the management doesn't support me, it's boring, it's not development, it's not exciting. We have a QA group who takes care of all the testing. There's plenty of excuses that people use, but that doesn't make them valid excuses. It does need to be built into the budget, so From experience, I can tell you that it's a critical part of the development process, and more so all the time as people realize the importance of unit testing. Of course, it's not the only kind of testing. We take our completed portion of the application and integrate it with other parts of the application to do integration testing, and then we look at all the parts together to be able to test the entire system in system testing, and then UAT, user acceptance testing, is kind of the gold standard of it's ready to deploy once the users have accepted that their testing is proven the code to be clean and valuable. So how do you make unit testing succeed? Keep it simple. A lot of testing is done just by getting onto a live system and trying stuff out. And that is problematic because those types of tests are not only time consuming, but they're not easily repeatable. So with JUnit, you can create tests that run at the click of a button and rerun anytime you need them. Plan for it. You know, having some kind of a test plan in place and allocating time for developers to do their testing is important, and then document it. Unit test plans will define all sorts of things, including, you know, what's expected to happen. And they'll give us a way to back up and regression test when we put in, say, a new version of our software, to go back and make sure that in adding these new features to the software, we haven't broken anything that was working before. So a lot of organizations have some kind of a standardized approach to what their test plans will look like. That's not our main focus here, just a little background. Thorough and automated testing. The key here is that we want to be able to test every line of code. That's the goal. It's rarely a goal that you can achieve, but that's the goal. And there are two general areas of testing. One is positive tests. You know, if we provide good data to our application, will it do the right thing and, you know, update our database, whatever it's supposed to do, give us a proper result. That's actually the easy part. Making sure that things work when they're supposed to is the easy part. The tricky part is the negative tests. What are all the possible things that might go wrong, and how is our code going to respond and react if and when they do go wrong? Just figuring out what those things are, and then further how you're going to handle them, is potentially a big task. We want to test for all possible values. You know, when you have a range of values or a size limit on the length of a character string, all of those possible values need to be tested. We'll talk more about that in a few minutes. And critically, we want to automate the process. We want our unit tests to be repeatable, to be capable of supporting regression tests when that's needed. And that's where a testing framework like JUnit can come into play. JUnit provides a graphical user interface that gives you a kind of a yes or no answer. Everything was fine, or something was wrong. And when something was wrong, it gives you all details about what was wrong. You may have a unit test suite of 1,000 tests and 3 of them failed. It's a pretty good percentage, but you will get an indication that 3 tests failed, and then the details of why. What the JUnit tests do, and what automated testing needs to do, is compare the results of what actually happened when you called your business method to what you expected the results to be. This is the bottom line. We're always comparing what we expect, what should happen, what the requirements say should happen, with what actually happened. And when we get what we expected, then we have a test that passes. Now, JUnit uses Java, so we write test classes using Java code to test our business code, also written in Java. And that means that all of the knowledge that you have of how Java works comes into play to allow you to write these test cases. And that is a benefit. You know, you leverage your Java knowledge. And it also eliminates that requirement that you repeatedly have to re-enter test data every time you try to run a test again if you did have a bug that needed to be fixed, something like that. So the ability to reuse these test cases after you've addressed your bugs or after you've made an upgrade and you want a regression test is another major benefit. All right, a few best practices, and we'll come back with a few more later on. Again, a written test plan. A separate test case for each class being tested. So if I have a class called product, I'm going to have a class called product test, and its sole job is to test the product class. If I have 100 classes in my application, I've got 100 test classes, each of which tests one of those domain classes. Separate tests for each path through the code. You know, a method has if tests and branches, loops all through it, and it's tempting to test each method thoroughly with a single test, but that leads to problems. We'll talk about those later on. So if you have one business method to test, you may have 5 test methods that test it in your test class, especially for the possible negative outcomes. Now, as you maintain your code, or as you are developing your code, you need to keep your test cases in sync with the code so that you have tests that match up with the code being tested. And you will spend as much as 80% of your development time doing testing. So those test cases are highly valuable, and having those controlled by your source code management system is critical. Even though you don't deploy them, you do need them when you do your next round of changes somewhere down the line, next month, next year, or whenever that is. So we want to automate, we want to regression test periodically as we make our changes and make sure that we haven't broken things that used to work as we're developing new components in our application. So we're going to focus on JUnit for the rest of our time. The JUnit framework has been around for almost 20 years, and you see Kent Beck and Eric Gamma mentioned as the kind of the founders of this, the founding article back in 1998. What JUnit does is give you a way to describe how your code is supposed to work and automatically report the testing results when you run those tests in a graphical user interface to make it easy to track down where the problems are. May or may not be easy to fix those problems, but tracking down where they are is the job of the framework. So just a quick step-by-step of how you'd go about this. You'd create a business class according to your design and analysis, and then just stubbing the methods. You know, don't write the methods yet. Then you create a test class for that business class, and we'll talk about how to structure that within your project in Eclipse. Then code the test methods, run them against your business class, and make sure they fail. This is along the lines of what's called test-driven development, where based on the requirements, you can know how things are supposed to work, even before you've written a line of code. So you write all the tests in such a way that if the code were written and running correctly, the test would pass. Now you don't have any code yet, you just have stubs that you're going to have to code later for the business methods. And step 4 is to implement those methods little by little, one by one, and then rerun the tests to make sure that your code passes the test. So this is an iterative loop where you code a little and test a little. And a best practice, you develop your test class side by side with your business class. Whether you write the business code first and then the test code is not as important as not spending 3 weeks furiously writing lots of Java code and then say, well, I guess we ought to do some testing. Let's see, where do I start? Work in tandem between your test class and your business class. Now, the basic JUnit framework provides a set of assertions, assert methods. You see the 6 of them listed there on the right that compare what actually happened with what you expected. So we'll look at these methods in more detail. Assert equals at the top of the list is probably the most frequently used of these, but there are a number of others, and we'll look at what each of them does. And what they do is they take an expectation and test it. Did we get the value we expected? And if that test is not true, then the framework, the JUnit framework, throws an assertion failed error. It's not even an exception. It throws an error because your code is written to check for exceptions, maybe even check for the generic superclass exception. So if the framework were to throw an exception, your code might consume it. Most Java code does not test for error. Errors are a more severe case than exceptions. So the framework throws an error, and then its test runners catch those errors and deliver the information about what the source of the error was, where it happened, why it happened, that kind of thing. So these assertion methods take arguments. And if we look at the next slide, you can see assert equals takes 2 arguments. What did you expect and what did you get? Now what you expected is something that you can determine based on the requirements. What you actually got is based on calling the method that delivered the result. So that actual value is then compared. If you have, for instance, a setter method that's supposed to test a value and not allow that value if it's out of range, then after the setter method runs, you would check the actual value, often by calling the getter, and making sure that the value did not get set because we gave it an invalid value. Now, assert equals is powerful in that it supports not only primitives, but also objects. And it compares primitives with an equal operator, and it compares objects with the equals method. So it's intelligent in that respect. Now, one of the differences between using assert equals with certain primitives, and they're listed here, float and double. Floats and doubles are representing what most of us need to understand as decimal numbers, 0 through 10 and so on, which are stored in a binary fashion. So they're often off by a tiny amount at an extremely insignificant digit. And because of that, when you're doing a assert equals and using either of those 2 data types, you have an additional parameter that indicates how far apart they're allowed to be. If we're comparing 2 dollar values, they're allowed to be off by perhaps 1/10 of a penny or something like that. So those are, that's one of the ways in which assert equals is overloaded, so that if you're comparing these floating point type values, you specify an allowable difference. Now, assert same allows you to compare two object references and make sure they're pointing to the same object. Assert true and assert false allow you to pass a single argument that evaluates to either true or false. Here's a couple of examples on the next page. See down at the bottom we have assert equals Jones emp.getName, and assert true emp.getSalary less than 50,000. So the first example has two arguments, the expected value Jones and the actual value. We might assert, and we'll see a complete example. We might do this assertion after we call set name on the employee. Back at the top of the page, a couple of other assert type methods, assert null and assert not null. We may not be interested in the exact value that we got. We just want to know, was there a value or not? And fail. Fail is like an assert method in that it can throw an assertion failed error, but it's different because it always throws an assertion failed error. Where the assert methods don't always, if things match up the way they're supposed to, they don't throw that error, where fail always does. And this is particularly useful when you're testing exception handling. You might fail if you have code in the try block that should have been bypassed because you should have caught an exception and dove directly into a catch block. We'll see an example of that later on. Now, all of these methods, including fail, are overloaded to support an additional parameter, which is the first parameter in all cases, which is a message string that you can code to indicate to yourself or whoever's doing the testing some further information about why the test failed. That message will show up when and if a test fails. Frankly, you don't need them that often because the framework does a pretty good job of saying, I expected this, I got that, which is different, it happened on this line, and here are the two values if you want to compare for yourself. So it's there in case you need it, but it's not always needed. Now, a little bit more recently, there has been an addition to the JUnit framework referred to as Hamcrest matchers. You can see down here in the package names org.hamcrest and org.hamcrest.core, which those packages contain some additional capabilities, including a whole different structure for how you do your assertions. One of the key things here you see at the top, more readable. And these assert that assert that type of approach to doing your checks is more readable. You see some examples at the bottom. These are the only examples that we'll look at for assert that. Going back to the previous examples for just a moment, you see we have assert equals Jones emp.getName. It's not particularly readable. If you've done JUnit testing for a long time, it's pretty clear what that means. You want to assert that the getName returned Jones, but it doesn't roll off the tongue to read that line of code. Down here on slide 16, assert that the emp age is 30. Assert that the emp job is equal to manager. Assert that the name either contains an X or starts with a Z. Assert that this list of objects has an item containing Jones. So much more readable and very capable. You'll see on the next slide we have a number where you see is equal to, either, contains string, starts. There's a couple of dozen of those for doing all kinds of different testing. Yeah, here they're listed on slide 17. And I won't go through all of these, but you can see that there's probably about 20 of them that are listed, and then the yellow boxes off to the right, JSON, XML, XPath, Excel, additional matchers have been created by third parties, by other available open source to do additional types of JUnit testing with these other technologies: JavaScript object notation, extensible markup language. Drawing a blank on XML, even though I've been using it for years. Again, I'll leave these to you just to give you a sense of what's available. We've listed these out for you, and they are combinable. We saw either, you can see and or, both, and so on. So you can write some very complex conditions with these. All right, I'm going to leave that behind and move on to an example. Here we have a business class that we're testing. The name of the class is product. It's got a few fields: ID, name, and cost. It's got a constructor, but our focus is on the setter. We have a setter that makes sure that the name is not null, not too short, not too long. So it does these 3 tests to make sure that the name fits with our requirements, being between 1 and 15 characters. Now, we have planted a defect in the code where the arrow is pointing at, it's checking that the name length is less than 0, which, as you may know, is not possible. The length of a string can be 0, but it cannot be negative. So that should actually be name.length less than 1. But we have a defect that we're going to uncover with our test code. So the other getters and setters and any other code is not at issue here. We're just, the setter for name is what's being tested. You can assume that there's a getter for name as well. Now in Eclipse, you can generate a JUnit test case automatically. And you notice there's radio buttons for JUnit 3 and 4. The JUnit 5 is not supported yet in Eclipse, although it will be in the next version of Eclipse from what I understand. Notice too, there are checkboxes we've checked off for setup and teardown. I'll talk about those a little bit more in a minute. When you click the next button, you get a screen that allows you to pick which methods you want to test. So you identified on slide 19 the class under test at the bottom is product, and the name of the test case is product test. That's a standard naming convention. And now, using reflection, Eclipse looks at the product class and gives you a set of checkboxes to identify what methods you want to test in this class or even in its parent classes. In order to use JUnit, you need a library to be added to your build path, and Eclipse, in this case, noticed that we don't have that library on the build path, and it offers to add it for you automatically. So it will build, based on what we checked off there, setup, teardown, and test set name. It even writes the method on line 20, test set name, and puts a fail statement in it so that you can run it and it will fail. Now, since Java 5 came out, Java annotations have found their way into just about everything, including the JUnit test framework. So you notice the before, after, and test annotations are included in the code, but the way the methods are named on lines 12, 16, and 20, this test case can also run under JUnit 3, which based its determination on how to run on the method names that you use. Setup and teardown are method names that it looked for, and on line 20, test set name It ran as a test any method that started with those 4 letters, test. So in this example on the lower left, we have packaged this up in a separate package. But a better way to handle this is to have a separate source folder. You see that on slide 23. To have source SRC contain your business code and a separate source folder called perhaps test containing all your unit test code. And then when it's time to deploy, clearly would deploy from the source folder and not from the test folder. Again, JUnit 3 is still supported. There would be a legacy of JUnit 3 style test cases likely to be in your organization, and you can continue to build those today. If you took this approach and chose the other radio button, here we've checked off the constructor and all 3 setters, then that would generate a test class something more like this. In JUnit 3, you notice on that 3rd line, public class protest extends test case. So it handled things very differently. No annotations. Set up, tear down, and then all the methods. Those bottom 4 methods start with the 4 letters TEST. And that's what indicates in JUnit 3 that this is a test case. And we want to run it as a test case. So we can run this, and again, you notice that they all have a fail statement, not yet implemented. And this is what we would see. On slide 26, we see the red bar at the top. All 4 runs failed. And that's what we expected. We did not have any code written to actually test. Now you notice that we've got all 4 tests are showing up here. Test product, that's the constructor, test set name, set ID, set cost. Whichever one of those you select, and we've selected the first one here, is selected. The failure trace at the bottom indicates the details of why that failed. If any of them did not fail, they'd have a green check mark, and there would be no failure trace for that one. So this says at line 16 in product test, there was a problem, and the problem was that we had a fail statement in there. So what we're looking for is a green bar. If all 4 of these succeeded, then we would have a green bar. So what do you need to test? Well, anything that does work. Both the good data and the bad data inputs have to be tested. You want to test at the boundaries. The length of a string, the value of a number, the size of an array. And you want to test at the minimum and maximum, just beyond the minimum and maximum, and somewhere in the middle. So in terms of constructing a JUnit test, it's best to begin by calling the business method. Now you may have to do some setup, and we'll talk about that, but you call the business method, then you call one or more assert methods to determine whether the business method ran the way it was expected to run. Assert equals is very common with or without that additional failure message. And again, if you have floats or doubles, that additional argument that says, well, they can be off by a penny or $1. And also assert that. Once you get used to that approach to coding, you never go back. So again, here's the method that we're testing. We're going to run this through some unit tests, and again, the name is not allowed to be null or too short or too long. At this point, we're not throwing exceptions. We're just returning value. It's a kind of an old-fashioned, hokey, non-Java way of doing things, but we'll get to exceptions later. So we're going to return a -1 if it fails, and we're not going to set the name. If all the checks succeed, then we'll go ahead and set the name, and then we'll return the 0 that we had set up as in the initialization. So here's a first look at testing. Test set name is the method being tested, and each of these blocks of 4 lines of code is doing a different test on setting name. First thing you have to do is have a product. If you're going to test anything about product, you have to have a product instance to do that with. So we instantiate this little product, and then we set the name to the maximum length. We expect that the return code is going to be 0. So we call set name. This is where we call the business method, pass it valid data, and receive the return code. The return code should be 0, and if we get the name, it should be not printer, which it was originally, but length is 15 chars, which is what it should have changed to. Now briefly, we test again with a name that's too long. We expect a -1, and the name has not changed, still 15. We test with null. We expect a -1, name didn't change. We test with an empty string. That should fail. And this is where our code being broken causes this test to fail, because an empty string gives us a return code of 0 because it doesn't fail, and it actually would then change the name to an empty string because our code was written incorrectly. And that's the problem with taking this approach. There's a couple of problems. One is that each of these little blocks, 4 lines of code block, depends on the results of the previous block being okay. If something goes wrong in a previous portion of the code, then a test may fail due to that dependency. The other problem is, as soon as this line fails, because the return code is going to be 0, that's it. An assertion failed error is thrown, and there's no further code executed. So these other assertions and these other tests don't even happen. So this is not a best practice. We're giving it to you as a first look, but it's not the best practice. The best practice, and this shows the failure where 3 of them succeeded, but the test set name failed. We then go and fix our code, run the tests again, and now test set name succeeds. A better way to handle this is to have a separate method for testing each path through the code. So here we're testing set name with the maximum length of 15 characters. Here we're testing a set name with a name that's too long, 16 characters. Here we're testing with null. So each of these separate tests can fail on its own, and the subsequent test will run as well. We've got 6 tests here. All 6 will run. Whether one fails, again, the empty string test is going to fail, but the minimum length, the name in the middle, all of those are going to succeed. Now the note on the right is that each one of these tests now is creating a product object. So this code, this one line of code that creates a new product object, is repeated 6 times. We know how we feel about code that is duplicated. Whoa. Sorry about that. I'm not sure what happened there. So what we'd like to do is not have that code repeat, and this is handled with something called a test fixture. If you need to test the methods of product, how do you do that? Well, you have to instantiate a product. And what if that product refers to other objects? Then you'd have to instantiate those as well. So what that's saying is that while in this case it's a pretty simple scenario where we instantiate the product in one line of code, we're done. In other cases, setting up a test may involve 5, 10, 20 more lines of code. So repeating one line 6 times may not be too, may not look too bad, but repeating 15 lines of code 10 times, can add up to some real duplication. So what a test fixture does is it sets up in one place a method called setup, runs before each and every test method, and that's where you would instantiate your product. Then the framework will call one of your test methods, then it will call teardown, which is frankly not used in most cases, and then it will call setup prior to the next test and run the next test. So here's our test fixture, P, whoops, and here's our setup method that does the instantiation. Teardown, not necessary, because what runs after teardown is set up for the next test. So unless you're doing some kind of database work where you need to insert rows in the setup and delete them on the teardown, typically teardown is not used. And then we actually use our fixture here. In test set name max length, you notice we're not instantiating a product. We're just counting on P to already be there because it's an instance variable and it's instantiated in the setup method, which ran before the test method. We only have about 5 minutes left. Quick note on constructor testing. Constructor should call setters. You want to make sure that the constructors work correctly. You don't want to retest all your setters in your constructor tests. With exception handling, this is where fail comes in. Now our set name method does a similar set of checks, but instead of returning a -1, it throws an exception. So if we call set name with a valid name, then going into the catch block would be failure. But if we call set name with an invalid name, then not skipping over this fail statement and going into the catch block would be failure. This is where it's particularly important to make sure that you enter the catch block. And then in the catch block, you may want to assert that the message is what it's supposed to be. You may or may not care exactly what that message is, but here we're saying that message in the exception should be name : null. Now with version 4, we have some annotations, additional capabilities because of the annotations. Here we have the same set name method, but with the test annotation, there is an attribute called expected, where you can specify that we expect this exception to be thrown. Then test set name null can eliminate the whole try catch structure and just say this test passes as long as it throws an invalid parm exception. So it simplifies your testing, but it does not give you the ability, like we saw on the previous page, to check and make sure that the message is what you expected. So we can take that a step further, and I won't spend much time on the rule annotation, but there are additional annotations, including this one, where you can use the expected exception type, set it to the type of exception you're expecting, and then specify what message you're expecting to come back. Then when you call the set name method with the invalid value, this test succeeds as long as it throws that message and as long that exception, as long as it has that message. And you can see that the Hamcrest matchers are also supported there, starts with. Now, there are additional capabilities in JUnit. You can use the ignore annotation to temporarily keep a test from running. The test annotation has a second attribute called timeout, where if it runs for more than a number of milliseconds you think it should run, you can have it fail for that reason. And it also supports an assume that method. And this is different than assert that. This is assume that. So a little bit lighter. Basically says if my assumptions fail, then just ignore the test. Don't fail the test, just ignore it. And just a few other things mentioned at the bottom, rule, parameters, theory, category. We wouldn't have had time to get into those, but we really don't have time to even begin to have a discussion of them. Therefore, doing more advanced testing with large blobs of data and capabilities to cross-test with a lot of different types of data. Just briefly as we wind up here, test suites follow the assumption that you don't just test one class, you might want to test all 15 classes that you wrote together. And while it's easy enough to just click the test button, it's even easier to click the test button once and have 15 different test suites run. So again, the Eclipse wizards will help you by identifying all of your test classes that are in the project and building a class called all tests that by default will run all of those individual tests. You can pick them. This is the version 3 approach where it all runs inside of the suite method. The version 4 approach is completely different. Matter of fact, it uses an empty class and simply annotations that specify which test cases you want to run. So here we have customer test, product test, order test as all being requested to run as part of the suite. All right, just wrap this up with some best practices. You have a separate test case for every class. Keep your methods small and focused. Use test fixtures to minimize repeating the same code in every test. Each test case should be autonomous and not depend on the other test cases. And you can control the order in which tests run, even though you typically don't need to. There are ways to do that. JUnit 5 is really changing things up. It is going to continue to support the way things had been happening, but it's also going to provide additional capabilities and additional support for the new features that have been added into the Java 8 version 8. So some of the annotations are renames. Those are listed on the top. Some of them are new. They didn't exist before, and there's a little bit of detail on those. You certainly won't be maintaining anybody's old JUnit 5 tests because they're not there yet. But just to let you know that things are coming and they're going to be able to change a little bit how we do things and give us some new tools for JUnit testing. All right, we cover this material in more detail and with exercises to support what you're learning in our intermediate Java course. We've given you a link to that. Also, I've given you some links to JUnit documentation online and a little bit more detail about our catalog at Themis, where we have again, a variety of mainframe and distributed courses available, a few of which are listed here. All of the popular frameworks in Java are included down there at the bottom. So there we go. Thank you for coming. I will hang on if you want to put some questions out there. Let me see. Looks like I may have a question. Yeah, people are asking for a copy of the presentation. That is available. And again, just go to themisinc.com, click the webinars, and you'll have the slides available there. Again, we've had dozens of past webinars in Java and many other mainframe type topics, so you can get at the video presentation for those as well as the slides.